In this video, we are going to be learning about a new unit of measure on how we measure angles. Tomorrow you will be quizzed on this skill, so you want to make sure that you're paying attention closely. Pause the video at any time, and please remember you can rewatch this video at any time until it sinks in. So I want to start with degrees. We already know a lot about angles and degrees. Thinking about this unit, we know that a full circle all the way around is 360 degrees for one angle inside. We also talked the other day in class about how a semicircle measures 180 degrees inside of a circle. So now we have this new idea. So degrees is one way to measure angles, but we also have something called a radian. So a radian is another unit to measure angles. So as you can see in this diagram, you see 1 radian is much bigger than what a degree is. Typically what we say is that 1 radian is the length along the arc of 1 radius of the circle. Here's what 3 radians look like. All the way around, it almost looks like a semicircle, and it gets close, but not quite. So if you think about it, 3 radians and a little bit more would make a full circle. And you might be thinking, well, what do we know that's 3 and a little bit more? Perhaps this extra piece is 1.14159. This might look familiar because a semicircle in radians is pi radians. So we have a relationship here that is formed. For every pi radians for an angle, it's equivalent to 180 degrees for an angle. So using this fact and using this equivalency, we can set up proportions to help us convert an angle that might be given to us in radians into degrees, and an angle that might be given to us in degrees into radians. There are different reasons for each and why you would want to use each. You're going to learn in class tomorrow a formula that only works for when angles are in radians, so it's going to be a useful tool to know how to convert a degree into radians if that's something you'd be interested in doing. So the way we do this and the way we convert radians, degrees to radians is we set up proportions. And it's good to always keep your proportions prepared the same way. I always like to set up radians over degrees. So anything that has to do with a radian will go in the numerator. Anything that has to do with a degree will go in the denominator. So here's the standard setup. For every pi radians, there's always 180. This fraction will always be present in your proportion when you're converting degree to radian or vice versa. Then what we do is we set that equal to what we're given. In this problem that we're doing, we're trying to figure out what radian measure equates to 60 degrees. So since I'm given a degree and I want a radian, I'll put the degree in the denominator because that's where degrees go, and I'll put x in the numerator because I want to know what radian is equivalent to that. Now what we do, since we're pretty familiar with our proportions, is we take the cross product and cross multiply. We get 60 pi equals 180x. We'll divide both sides by 180. It does tell us in the directions to leave our answer in terms of pi. You should always do that for radians unless they need a decimal. So what I would do in my calculator is I would type in 60 over 180 and hit math, enter, enter to simplify my fraction. And when you do that, you should end up in terms of pi with pi over 3. So what we just figured out is that 60 degrees in degrees is equal to pi over 3 radians. If you'd like to pause the video and try the next one on your own, just skip ahead to look at the final answer. If you'd like to watch the next example, I'll perform another conversion of 45 degrees to radians, again in terms of pi. You should always be leaving your final answer for radians in terms of pi. So again, I know I'm converting degrees to radians, so the first thing I set up is pi over 180. That's our standard conversion. For every pi radians, there's 180 degrees. And I know that I want to convert 45 degrees. So it goes in the bottom where 180 goes because they correspond to each other. And I'm solving for how many radians is equivalent to 45 degrees. We cross multiply. divide both sides by 180. Keep pi in there. We don't need to simplify it in our calculator, but we do need to calculate this 45 over 180. Again, we hit math enter in our calculator. This simplifies to pi over 4 equals x. Thank you for watching this video. Again, if you'd like to watch it at any time, you can do so. And we will be converting radians into degrees in tomorrow's class. Have a great night. See you tomorrow.